Okay, module 6, greatest common factor, level 1. Just a reminder about the notes points. You can either take down these notes or you can go into the lesson folders for the notes. There's been a couple of moments where, I do upload this as a PDF, but in order to get the points, you guys have to copy your own version of this, not just upload my PDF for later. Some people have done that. It's not hard points to get. All you have to do is copy it down.
I understand that, but like I wasn't here.
Yeah.
So I did upload the notes on Tuesday. I mean,
you can. I mean, any of the stuff that's uploaded. If you weren't here, I do post this PDF.
I did. What I did was I printed it out and made my notes, and then but you wrote it and I sent it to you. Is that you don't want that?
Well, you can print it up, but you got to copy it yourself. That's part of it's easy points, but you have to copy it yourself.
Okay, I didn't know that. So
I'm just clarifying, just for anybody that was, as we're getting started on module 6.
Okay,
because I will post this, but in order to get the points, you've either got to write it down now or you've got to copy my PDF later.
Right now,
one of those two.
I sent you a PDF yesterday.
Okay.
Of Tuesday's notes.
Of your notes or of mine? Okay, yeah, you just recopy it and then send it back in for those points. Okay, all right. Okay, so first instructions, factor the expression completely. Okay, so we've got 32 plus 40x. And basically what you're gonna wanna do is take out a common factor. So I said the question mark. Take out a common factor. So with the numbers like 32 and 40, they're both even. Anytime there's even numbers, you can always take out a 2. That doesn't necessarily mean it's the greatest common factor. You do want to take out the largest thing that you can take out. 4 goes into 32. 4 also goes into 40. So you could take out 4, which is larger than 2. So we're on the right track. Anything else going into both of those? 8. Yeah, 8 actually is the largest factor that we can take out of both of those. In some cases, you'll be able to take an X out of both, but here we can't take an X out of the second one. So there's only a number that we have in common. We can take an 8 out of both of those. And then basically what we're going to do is we're going to divide both of those terms by 8. So 32 divided by 8, anybody know what that is? 4. So that's going to go inside the parentheses. And then 40 divided by 8, 5. And we didn't take out the X, so we still have the X there. And then close parentheses. And that's the answer when we're factoring it. And if you wanted to check, you could distribute to check. So what I mean by that, if you take 8 times 4, that should give you 32. If you take 8 times 5x, that should give you 40x. So if you multiply and get back there, then you know you factored it correctly. This is basically the opposite of multiplication. We're sort of dividing. Normally we start here and you distribute the 8 and you end up here, but we're going in reverse. $70x minus 80. Same instructions, we're trying to factor this. So we want something that goes into both of those that we can take out. Anytime you've got numbers that end in 0, then that means 10's a factor. So 10 is a factor of both of these we can take out. They're even. Let me show you what happens if you don't take out the largest. Let's say we took out 2, because they are both even. 70 divided by 2, and I should have wrote that on the last one, but divide the common factor. So 70 divided by 2 would give us 35. We didn't take an x out, so we'd still have an x. By the way, this wouldn't be exactly the best way to proceed. I'm just showing if you don't take out the largest one. 80 divided by 2 would give you 40. So the only problem with this as a final answer is 35 and 40 have something in common. Anybody know what that is? 5. So that would mean that you didn't take out the largest thing. You can go a little bit further and take a 5 out. If you do take a 5 out, that means you're multiplying 5 on the outside and then dividing the 35. That becomes 7. Dividing the 40 by 5, that becomes 8. Not the way that I would recommend it. Take out the largest thing first, which was 10. 70 divided by 10 is just 7. We didn't take any x's out. And then 80 divided by 10. And you can look at the 7 and 8. They don't have anything in common. And if you wanted to check it, 10 times 7x gives you 70x. 10 times negative 8 gives you negative 80. So you know you factored it right. Greatest common factor level 2. 14x cubed plus 18x to the 4th. Pretty much doing the same thing with these numbers. Only you'll notice not only do we have a common number that we can take out, we've got x's in both of those terms, so we can take out a certain number of x's. If we look at 14 and 18, both even, so we can take 2 out. We've also got 3 x's on the first term. We've got 4 x's on the second one. So we can definitely take out an x. We want to take out the greatest number of x's. So hopefully you notice that we can take out 3 from the first. We can also take out 3 from the second. 3 is the most number of x's that we can take out. You wouldn't say x to the second because you can take out more than 2 x's out of both of those. You wouldn't say x to the 4th because we can't take 4 x's out of the first term. But 3 is the most we can take out of both. So x to the 3rd. And then we're dividing. 14 divided by 2, 7. We took out all 3 x's there, so we don't have any x's left on that first term. What's the next number going to be? 9. And then, yeah, there was 1 x left over because we took out 3 of them, left 1 behind. And 7 and 9, anything in common there? They're both odd, but we can't take a 2 out, for instance, or anything like that. So you do want to check just to make sure that you've taken out the largest factor. Just to reiterate, if the 7 and the 9 have something in common, then you'll want to take that out and multiply it by the 2 that you might have taken out before. Negative x minus 2x to the 4th. The software may take a couple different answers on this one, but generally, if you're factoring something that starts with a negative, you'll take out a negative. So let me write that on the side. if it starts with a negative, factor out a negative. In some cases that won't matter, but we'll get down the road with some trinomials where it will matter that you take out the negative. Number wise, nothing you can take out, but we can take an x out of both of those terms. Can we take out x squared? No, not enough x's there to take out x squared. So x is the only thing that we can take out. And this might not make a lot of sense initially, but when you take negative x out of negative x, just left with 1 actually. And one way to check that is if you take negative x times 1, you do end up back here. Negative x times 1 gets you back there. And anytime you take out a negative, I'll put this in red since this is probably a common error. If you take a negative out of negative 2, it becomes positive. How many x's do we have left? Okay, and then just in case you were a little unsure, negative x times 1 is negative x. Negative x times positive 2, x to the third, is going to be negative. Negative times a positive, negative. 2, and then the x times the x to the third gives you x to the fourth.
Basically, 1 holds the place of x inside the parentheses of the right.
Yeah, it's something you've got to have there. Sometimes people will say, you know, we took out negative x, so there's nothing there. But let's say if we did negative x, and then we're like, oh, well, we took out all negative x, so there's nothing left. Then there's just 2x to the third. Sometimes people will do that. But the problem with that is that doesn't multiply to get you back to this binomial. So you got to have the 1 in order to keep that first term. Keep it a binomial, right? Because otherwise, this would just end up being negative 2x to the fourth. That would be the only thing we'd end up with. That may not make any sense, but you guys will get enough practice with this to hopefully it'll clear up as you do it. Do another one of those. Negative 20 x to the second minus 6 x to the fifth. Nothing new here. So if you want to try to beat me to the answer, I'm not going to be explaining anything I haven't already said. So factoring something that starts with a negative, this is not 100% necessary here. Later on it will be, but if it starts with a negative, take out a negative. 20 and 6 are both even. So we know we can take out at least a 2. How many x's can we take out? X squared. Okay, so 2 is the largest thing that we can take out. We can't take out 3 out of both because 3 doesn't go into 20. Can't take 6 out of both because 6 doesn't go into 20. So 2 is the largest thing. And then we're just doing division. Negative 20 divided by negative 2 is 10. We took out both of the x's. What's the next sign going to be? Positive. Yeah, if you take a negative out of a negative, so negative 6 divided by negative 2 is positive 3. We took out 2 of the x's. Greatest common factor variable only. Hopefully not confusing at all. Just looking at both of those, so binomial again, we got one term and then another term. Can we take x out of both of these? Yeah, and hopefully notice we can just take one x out. We can't take x squared out. So that's the largest thing. How many y's can we take out? 3. Okay, then you just write in what's left. Okay, so then we're just doing division. We're saying, what did we take out of this one and what's left? So we took out the x, no x's left. We took out 3 of the y's. So that leaves 2 of them. And then on the second term, we took out an x. So that leaves 3 of them. We took out all 3 y's, so there's no y's left on that second term. So basically the same process, except there's no numbers, it's just variables. That's probably good for that, I think. Okay, so far we've just been looking at binomials. We had 1 term, 2 terms, so binomial so far. Now we're going to look at trinomials. Trinomials have 3 terms. X squared plus 9x plus 14. Trinomials typically factor into 2 parentheses. So I'm going to go ahead and write 2 parentheses under there. So we go from that 3-term thing to 2 parentheses. Okay, so the first thing in both of these I'm going to underline because both these parentheses are going to be binomials. You'll have 2 terms in the first parentheses, 2 terms in the second parentheses. So I'm underlining these first 2 spots. Those have to multiply to be x squared. They have to multiply to whatever the first term is. So any idea what 2 things can multiply to be x squared? X and x. Yeah, hopefully that's the easiest part of this for you guys. Another thing that can be helpful, if it's plus and plus, then you can just go ahead and put plus and plus in the middle of those. A lot of them you're going to have you won't have plus and plus, but a few of them you will, and you won't have to think about that part of it, hopefully. The last 2 things have to multiply to be 14. And this one, up here it says A is equal to 1. So I'll go ahead and write that in here. So I'm just meaning that the number in front of x squared is 1. So what that means is that, and I won't write all this stuff out every single time we do one of these, but so the first two things have to multiply to be x squared. The last two things have to multiply to be 14. Multiply 14. And what I'll do on a lot of these is I'll make a comprehensive list of the factors of 14. So I usually start with 1 and 14, multiply to make 14, 2 and 7, I heard somebody say, multiply to be 14. 3 doesn't go in, 4 doesn't go into 14, 5 doesn't, 6 doesn't, and then you're back up to 7. So once you get around, starting with 1, once you get around to the right side, then you're done with your list. This is comprehensive. We haven't forgotten anything. But since a equals 1, like I said back before, a is equal to 1. The number in front of x squared is 1. Then we just want choose the pair that adds to 9, which is this middle number. So what we want is, we want a pair that multiplies to be 14 and adds to 9. Two and 7 multiplies to be 14, adds to 9. No, that's a good question. You can put x plus 7 and then x plus 2 after it, either way. Okay, so I wrote a good bit on that one. I'm not going to write all that every single time because it's going to, the process is going to repeat. The first thing in both parentheses is going to multiply to be the first thing. The last thing is going to, the last two things in both the parentheses is going to multiply to be the last term, and then possibly add to be the middle term. So trinomial is going to factor into two parentheses. What's going to be first in both those parentheses? X. So those have to multiply to be the x squared. Are we going to put plus plus in here? Not on this one. Like I said on the last one, if you've got, both positives, pluses in the middle, you can go ahead and do that. I'm going to skip the signs for now. Going to jump to the last two terms. Those two have to multiply to be what? 20. And you might know what the numbers are going to be, but I'm still going to make a comprehensive list starting with 1 times 20, 2 times 10, 3 doesn't go into 20, 4 does, 4 times 5. And then once you've gone around to the other side, so we're up at 5, this is a comprehensive list. So I'm going to put the 1 there. We've got, I don't know if you guys can see that, but I put that invisible 1 out front. So if you've got a 1 there, then you're looking for a pair that multiplies to 20 and adds to 12. Close. Negative 12. So pick the pair that, on that. Pick the pair that adds to, what was it, 20? Or let me go back. That multiplies to 20 and adds to negative 12. And so, we haven't put the signs in, so they're not both going to be positive. We have to figure out what signs work. So, we're looking for a pair that we can make -12 out of. With the 1 and 20, if you add them, you can make 21. If you subtract them, you can make 19. So we can't make 12 out of that. With the 2 and 10, we can make -12 out of that. But both their signs would need to be negative. -2 times -10 gives you +20. So that part works. -2 plus -10 gives you -12. So -2, -10. Okay, make sure you guys stop me if you have questions on some of this.
When you're doing this from Deltamath, to put in the first, you do not have to put in the X and the sign, just put in the number, then comma, and then we'll bring up the other one. Otherwise, it would kind of be wrong.
Okay. Factoring trinomials where a is greater than 1. So the thing out in front of x squared isn't going to be 1 all the time. In this case, it's going to be greater than 1. So there's probably 2 different ways I could show you how to do this. I'm going to go ahead and show you the way that I do it. There's a little bit of a learning curve maybe with it, but we'll see how it goes. I can show you guys another way if you have trouble with this. So like I said before, trinomials typically factor into 2 parentheses. The first thing in both of those have to multiply now to be 5x squared. So the x squared part you're still going to get from x and x, but in order to multiply to be 5, what do the numbers have to be? Five and 1. That's the only way that we can make 5. You know, if you had a number like 12, there's a few different numbers that you could use to multiply to make 12, but with 5, it's nice because it has to be 5 and 1. Can we put plus and plus in here? Yeah, both of our signs up here were plus, so you can go ahead and put that in. The last thing in there, those have to multiply to be 2. So the nice thing about that, not a whole lot of options for multiplying to be 2. What do the numbers have to be? 1 times 2. Okay, so we do have to check this because I could have put the 2 first and then the 1 second. I could have done 2 and then 1 like that. So you will want to check this. And there's different ways to do that. I'm going to do it beneath here by multiplying. 2 times 1x is 2. And then 5 times 1 is 5. And I want these to add to 11. 2 and 5, does that add to 11? No. So what that means is when I put 2 and 1 in there, I'm going to want to swap those. Before I put the 2 first and the 1 second, now I'm going to put the 1 first and the 2 second. So now when we multiply the middle, 1 times 1, And then when we multiply the outside, 5 times 2, 10, and then that one works. So that tells you that the way that you've arranged things works. And I think you guys know, if it's 1x, you'll just put in x. Don't put in 1x. I'm not sure if the software will take it if you put in 1x. Might tell you there's something wrong with that, even though technically that's correct. Okay, 3x squared plus 20x plus 12. Going to factor into 2 parentheses. The first 2 things have to multiply to be 3x squared. So the x squared part we know for sure is going to be x and x. What are the numbers going to be? 1 and 3. I'm going to put the 3 first. Yeah, it has to be 3 and 1 because that's the only way that we can multiply to make 3. And I think somebody mentioned it. It is going to be plus and plus in the middle. Last 2 terms have to multiply to be 12. If, you know, because here we've got, if we had a 1 out front, you'd be looking for 2 things that multiply to be 12 and add to 20. But since we've got the 3 out front, we're going to find some things that multiply to be 12, plug them in and see if we can make 20. So on the side, I'm going to write some multiples of 12, 1 and 12, 2 and 6, 3 and 4. And we don't know with certainty, but typically, I don't know if you can see that, but the closest pair is the percent. You'll see that more often than you will. 1 and 12 are further apart. 3 and 4 are close together. Percentage wise, those are the ones that they'll give you most often. So I'm going to try 3 and 4. And remember, we're going to multiply underneath. So 3 and 1 gives us 3. What's the outside number going to be? Three times 4 is 12. So we're hoping that it adds to 20, the middle number. So 12 and 3 doesn't multiply to be 20. So what you can do instead is swap the 3 and the 4. We can do that. Put the 4 first and the 3 second. Then in the middle, we've got 4. On the outside, we've got 9. Still not a pair that can add to 20. So what that means is you might move on to the 2 and 6, and we're going to try those. So 4 and 3 didn't work. Moving on to 2 and 6. And by the way, if this doesn't work, we could put the 6 there and the 2 there. We'll just swap it if this doesn't work. So when we multiply in the middle, 2 times 1, get 2. When we multiply the outside, get 18, and that does add to 20. So a little bit of trial and error. Process will take a little bit of practice probably. But again, the first 2 things have to multiply to be the 3x squared. The last 2 things have to multiply to be 12. If you don't have this 3 out in front of x squared, you're just looking for a pair that multiplies to be 12, adds to 20. Since you've got the 3 out front, you're going to plug in your pair and then see down here if it works. Okay. We'll do one more section and then I'll leave the second half for Monday. Okay, so factoring trinomials, A is greater than 1, level 2. So first thing in both those parentheses has to multiply to be 3x squared. We know we're going to have an x and an x. Numbers in front of x have to multiply to be 3. 3 and 1. Can't put plus and plus in here because we've got minuses in the middle. So we'll skip the signs just for a minute. At the end, the two numbers have to multiply to be -2. So not a whole lot of options there. Has to be 2 and 1. But try to remember, you could have put the 1 there. You could have put the 2 there. So I'm gonna highlight the fact that the number in front of x squared isn't, let me use the actual highlighter. The number in front of x squared isn't 1. So we're gonna plug these numbers in and then check underneath. So 2 times 1 is 2. And then 3 times 1 is 3. And we want these to add to whatever number's in the middle. So in this case, -1. So we want these to add to -1, which they could, because we skipped the signs. They weren't going to be plus and plus. So we can decide what these signs are and see if they work. So if we want them to add to -1, if you make the 3 negative, 2 and -3 adds to -1. So if that's how it works, try to keep in mind that the -3 now has to come from the 3 and the 1. That's where we got that one. The 2 came from the 2 middle ones. So what's the sign on the 1 need to be then? -1, right? And that 3 times -1 now gives us this -3 that we needed. And then we need a +2, so the sign on the 2 plus. (5x squared minus 9x minus 2). First two things have to multiply to be 5x squared. We know we've got x and x in order to get the x squared numbers. 5 and 1 are the only options of things that multiply to be 5. Last two things have to multiply to be -2. By the way, I'm skipping the signs again because we know it's not going to be plus plus. So we'll figure out what the numbers are. It has to multiply to be 2. So these have to be 2 and 1. But keep in mind, you could have put 1 first and then 2. So if this doesn't work, we'll just swap those. Underneath, we've got 2. What's underneath the 2 here? 5. Yeah, multiplying the outside, multiplying the inside. And we want these to add to, what would they add to here? -9. Add to -9. So with 5 and 2, depending on what you do with the signs, if you add them, you can make 7. If you subtract them, you can make 3 or -3. But you can't make -9. So we'll go ahead and swap these. Put the 1 first and the 2 second, and then we'll see what numbers we get underneath. So in the middle, when we multiply 1 times 1, be careful you don't put 2. I see that a lot. 1 times 1 is 1. And then on the outside, 5 times 2 is 10. We can make -9 out of that. Which one would need to be negative? 10. Yeah, 1 minus 10 gives you -9. And the -10 came from these 2. So the 2 will need to be negative. 5 times -2 gives you -10. And we want the 1 to be positive. Okay, I'll go ahead and stop right there. I'll post these notes. This is just part 1. We'll do part 2 on Monday.